All right, so we are continuing on in our notes from yesterday. Since this is a video, I'm not going to go, sorry, I know this is blurry, I'll fix it in a second. I'm not going to go as painfully slow as yesterday because people who are doing this on notebook paper can just pause and write out as many or as little details as they want. So I will leave that up to you. You do have that graphic organizer that we did yesterday, this thing, with our examples that we wrote out, all the words. And so for the examples today, put as many words as you need for it to make sense, so that you can do the practice problems. That's kind of the goal, okay? So we did the 3 examples for direct variation yesterday. Now we're going to do 3 joint variation examples, and then we're going to do inverse and combined. So you are going to need a calculator for this, just to do, multiplication, division, that sort of thing. Nothing too crazy. So we're going to do the same thing we did yesterday, where we're going to do the problem in 2 parts. The first part to kind of set up the problem and figure out that constant, that k value. And then the second part of the problem to go through and use the k value and then solve the second half of the situation that they're giving us. So for joint variation, just a reminder that joint variation is typically, just the most simple case is going to be y equals k times x times z, although that could be different depending on the context of the problem they give us. So we're going to read the problem and then change it depending. Sorry, alarm went off. All right, so if y varies jointly with x and z, so the way that this one is set up, the way that it's phrased, we are going to be writing y equals k times x z, and y equals 48 when x equals 8 and z equals 15. Find y when x equals 14 and z equals 20. So here's the first half we want to find. So I'm going to just divide by 8 and 15, divide by 8 and 15. And so when I do this, you have 2 different ways you can type this in. You can do alpha y equals to type it in like a fraction and do 48 on the top and then 8 times 15 on the bottom. And this is kind of nice because it's going to give you the k as a simplified fraction already. So we canceled out both of those. We get k equals 2/5. Or you can do 48 divided by 8 times 15 like that. And then you get k as a decimal, and you can leave it as a decimal, or you can hit the math button, number 1, and turn it into a fraction. So either way is totally fine. We'll probably do this a few times. So the formula that we're dealing with is y equals 2/5 for k times x times z. So now I'm going to take that formula, y equals 2/5 times x times z, and I'm going to take that and I'm going to find the y when the x is 14 and the z is 20. So now it's just kind of a plug and chug type of problem. I'm going to do 2/5 times 14 times 20. And you can type in the 2/5 like a fraction using the fraction button, or you can do what I did, which is I just typed it in using division. Same thing. We get y equals 112. Okay. All right, example 12. P varies jointly as Q and the cube of R cubed. Varies jointly as Q and the cube of R. P is 270 when Q is 6 and R is 3. Okay, so we're going to find k first. That's always our first goal, is to find that constant. So I'm going to divide by 6, and I'm going to divide by 3 cubed, divide by 6, divide by 3 cubed. And I kind of liked the convenience of typing it in as a fraction and already having that k as a fraction. So that's what I'm going to do. I'm going to do alpha y equals, and I'm going to type in 270 divided by 6 times 3 to the third power, 5/3. So 5/3 equals k. And so my equation is P equals K times Q times R cubed. Oh, sorry, not K, 5/3. 5/3 for the K value. And I'm going to go ahead and write my equation up here before I plug stuff into it. And then it says find P when Q is 3 and R is 5. So now to find P, we can just plug everything straight in. So 5/3 times 3 times 5 to the third. And we get P is 625. Okay. All right. For Tom's savings account, the interest earned varies jointly with the principal and the amount of time in years since opening the account. If Tom opened the account 3 years ago with $1,200 and earned $144 in interest, how much interest will he have earned 8 years after opening the account? So this problem is a story problem, and it's kind of tricky because there are variables in there, but they didn't tell us what letter to use. So in this case, it is up to you. And some students always like to use X and Y and Z, and some students like to use other letters. I like to use letters that represent the different things. So like here they say the interest earned varies jointly. So I'm going to use I. So I'm going to say I is interest earned. And sometimes when I do these problems, I don't really have to write down what my variables mean because they're easy to keep track of. When I read this problem, I felt like I lost interest halfway through. So this is a problem for me where I know that I need to write down what my variables mean. Interest earned varies jointly with the principal and amount of time in years. So principal, P is going to be principal, and principal in this case is your starting amount of money. Not principal like Dr. Davis, but principal as in starting amount of money. And then T I'm going to use for time in years. Okay, so I'll use I, P, and T, and I think that that will work. So let's go ahead and set this up. It says interest varies jointly with the principal and the time in years since opening the account. If Tom opened the account 3 years ago with $1,200, so he opened the account 3 years ago, there's your time, with $1,200, there's your principal, and earned $144 in interest. How much interest will he have earned 8 years after opening the account? Okay. So let's go ahead and solve for K. And divide by 1,200 times 3, divide by 1,200 times 3. So I'm typing it in the same way that I've been typing everything in. So that's 1/25. K equals 1/25. So we're going to have I equals 1/25 PT. Okay. So now it says, how much interest will he have earned 8 years after opening the account? Now, this is an interesting problem because they say, how much interest will he have earned? So I is clearly what we're trying to get this time. And it says 8 years after the account, but they don't tell us what to plug in for P. Now, the interesting thing about P is that in this type of context, the principal amount of money is not going to change. The amount of money you put in the account is the amount of money you put in the account. Like that's how much you start off the account with. So the $1,200 is actually going to stay for the second situation as well. 1,200 and then 8. So now we're going to see the interest for this one. 1 divided by 25 times 1,200 times 8. So the interest after 8 years is 384. So I'm just gonna write this with a dollar sign because this is money. So you'll have earned $384 in interest, not you, Tom will. We're talking about Tom here. All right. Let's go ahead and try the next set of problems. So these are inverse variation problems. So just a reminder, inverse variation is y equals k over x. So we'll go ahead and read the problems. Y is inversely proportional to x. Okay, so y equals k over x. If y equals 7.5 when x equals 8. Okay, so we're going to go ahead and start the first half of the problem where we solve for k. 7.5, x equals 8. So to solve for k, I'm just going to take the 8 and multiply it by the 7.5. So 7.5 times 8 means k is 60. So y equals 60 divided by x. So the formula we're working with is y equals 60 divided by x. And so now we're going to find x when y is 5. So 5 equals 60 divided by x. So if I want to get the x alone, I'm going to go ahead and multiply each side by x. So 5x equals 60, and then I can divide it by 5. So x equals 60 divided by 5. So x equals 12. Okay, so that one took a little bit more work because we were not solving for y, we were solving for x. So we had to get that x alone, but x equals 12. Okay. This one's a little bit more difficult because it doesn't just say y is inversely proportional to x, it says m is inversely proportional to the square root of n. So m is inversely proportional to the square root of n, Okay, m is 27 when n is 16. M is 27 when n is 16. Okay. So the square root of 16 is 4. So we're just going to take the 4 and multiply it by the 27. So 27 times 4 is 108. So k equals 108. So m equals 108 over the square root of n. And now they say find m when n equals 64. So we're going to do 108 divided by square root 64. So basically 108 divided by 8 which is 27 over 2. You could turn that into a decimal. That's 13.5. So you could say 27 over 2, or you could say 13.5. Both of those are good answers. Okay. All right, let's go ahead and do this story problem and see if this one's easier to track with than the last one. So it says the time it takes Adam to drive to Disney World varies inversely with his average rate of speed. If it takes Adam 10.8 hours at an average speed of 50 miles per hour, how long would it take him at an average speed of 60 miles per hour? So we've got time and speed. I'm still going to write this down. Okay, so we have time it takes, and then S is going to be average speed. So like I said, I like to choose the variable that I'm using to relate to what it stands for. That's easier for me. So it says the time it takes Adam to drive to Disney World varies inversely with his average rate of speed. If it takes him 10.8 hours at an average speed of 50 miles per hour, okay? So that's the first scenario. Now we're going to solve for k. So I'm going to take the 10.8, I'm going to multiply the 50 to the 10.8. So 10.8 times 50 is 540. So we have t equals 540 over s. Okay. Now it says how long would it take him at an average speed of 60 miles per hour. So now we're going to solve for the time, but we're going to do 540 over 60. So 540 over 60 is 9, so it would take 9 hours. All right. We filled this part out on the graphic organizer, but a combined variation is a relationship that contains both direct and inverse variation. So, for example, y varies directly as x and inversely as z. So y varies directly as x and inversely as z. So I think of, when they use the word directly, I think of multiplication. When they say inversely, I think of division. P varies, let's say P varies inversely with Q squared, and then directly, remember directly means multiplication, directly with R cubed. So they said it kind of backwards, but we can still think of it that way. So inversely, that's division, with Q squared, directly with R cubed. So the directly kind of bumped the multiplication, it made that multiplication, it put it back on the top. All right, let's do this last problem. A varies directly as B and inversely as C. Okay, if A equals 16 when B is 12 and C is 6, okay, so we got to find K. Well, we've got 12 divided by 6. I already know that's just 2. So we have 16 equals K times 2. So I can go ahead and divide by 2, divide by 2. So K equals 8. So what we have is we have A equals 2 times B over C. Not 2. 8. Goodness gracious. The 2 was right here. It was not the answer. The answer was 8. Okay. So we solved, we got k is 8. So now we can go through and we can find a when b is 28 and c is 4. 8 times 28 divided by 4. So I'll just type this in. 8 times 28 divided by 4, we get 56. A is 56. And we are done. Those are the notes. So now, with the rest of the period, you guys are going to finish the assignment from yesterday. You did 1 through 14. You're now going to finish the rest of the problems on that worksheet. And then there was a second worksheet that was just inverse variation, and you're going to only do 1 through 8 on that. All right, so 2 worksheets. Finishing the first worksheet, doing the second worksheet, you're going to hold on to those and you're going to turn them in tomorrow when I am back. All right?